Hi, hello everybody. So this is the video dealing with section 10.3, geometric sequences in series. And this is the second part where we are interested in finding the sum, two types of sums. First, we're going to see the sum of the first n terms of a geometric sequence. And then we're going to find the sum of a geometric sequence, but without end. So it's going to be the complete sum of the complete sequence. All right. Now, normally when we find the sum of the terms of a sequence, we call it a series. All right. So for example, if we are trying to stop the summation on the first n terms, so for example, let's find the sum for the first 10 terms, 20 terms, 30 terms, and so on and so forth. We use this formula here. Okay, and we indicated by Sn that this summation stops at the nth term. So formula is A1 times 1 minus R to the n over 1 over R, provided that the ratio is not 1. Okay, the ratio is not 1, we cannot do that. So these are typical examples. All right, this is one example taken from your textbook. It's just an application um, example so that you can use the formula. And the question is find the sum of the first 18 terms of the geometric. Now, on this geometric, I don't have to tell you that this is a geometric sequence because you should be able to, by looking at the terms, to identify this as either a arithmetic sequence or a geometric, because these are the only ones that you're responsible for in this course. This is clearly not an arithmetic sequence because there is no common difference, fixed difference, but this is a geometric sequence because the common ratio is 4, as you can see. So I don't have to tell you that this is a geometric sequence. So on the exam, I'm going to say find the sum of the first, for example, 18 terms of this sequence. And you have to know that this is the formula we have to use. So the question becomes find S18. The first term is 2. Let's just erase this from here. The first term is 2. 1 minus, I have to find the ratio. Now, the ratio is always a sub n divided by the previous. In this case, minus 4. Now, be very careful, right? This is the minus from the formula, and here's your minus 4 raised to the 18th power, and over 1 minus 4. So you got to be very, very careful. This is minus 4 plus, right? There's a 2 here, 1. Now I have to evaluate minus 4 to the 18th first. This is going to be a positive number, and then I'm going to do 1 minus that. I guess you can do that on the calculator if the calculator can handle it. So let's see if the calculator can handle this. I am going to be very careful, right? If you do this, minus 4 to the 18, you're going to get the wrong answer. This isn't the answer. All right? The answer is positive here. So you have to do parentheses minus 4 to the 18. All right, so that thing entered it incorrectly. So minus 4, and then close parentheses 18. So this is the answer that you want. So it's a positive answer. Now, as you can see, it's a problem because it has an exponential format, but I'm going to divide. So first I have to subtract it from 1. So this is what I wanted to do. So I'm going to do this again for you to see. Minus 4 and closed raise 18. This is going to be a negative answer. And that I am going to divide. I have to multiply by 2, but I'm going to divide by 5 first. So that the number is still big. And then I'm going to multiply by 2. All right. So let's see if we can make sense out of this thing. All right. You cannot write this answer on the exam, negative 2.7487. So you have to do something else. So I'm going to write it here. Minus 418. And so this is what I have to write. The problem is I cannot do both at the same time. So I am going to do the following thing. Okay, so minus 2 points. So 27, 48, 70. So 2 point. So it's going to take a while because I have to show you. So let's see, 74, 877, 907. And there's e to the 10. This means there is 10 zeros after the decimal point. Okay, so this decimal point is going to move 1, 2, 3, 4, 5, 6, 7, 8. Now, unfortunately, there are two other digits the calculator doesn't show here. They're not zeros, but for now we're going to pretend that they are zeros. So 2, 7, 4, 8, 7, 7, 907, and I'm going to put 0, 0 here. Okay? I don't think these are zeros, and we'll discuss this, in class if necessary. But this is the answer that we want to see, not this one. Okay, so the answer has to be either a whole number or a fraction. So, this is what usually happens with the geometric sequence. If you ask for a very big number, we're going to have this problem. And I'm going to show you now that the answer may not be 0, 0 because I'm going to use a scientific calculator. Okay, I'm going to calculate this 1 minus 4 to the 18 for you to see exactly what we need to show. And it's very useful to bring a scientific calculator to the exam, or you have to find out exactly how to make the TI-84 present the answer in standard form. Okay, so I'm going to do 4 or minus 4 to the 18, but it's going to be a positive number, 4 to the 18, and here's the answer. This number. Okay. This number I have to subtract from 1. So I'm going to do 1 minus it, which is the same thing, but the answer is going to be negative, obviously. And this I'm going to divide by 5. All right. And then I'm going to multiply by 2. So this is my correct answer. So look what the answer is compared to the one that TI-84 gave me. So 27, 48, 7790, and then my 694. Yeah, right? So the correct answer is minus 274, 87790. Where is it? The other one. 694. So you have to be very careful. And I recommend bringing a scientific calculator when you have to do problems dealing with the geometric sequence, because if we ask you a very large number, then the situation may be this. Obviously, if we ask you for something small, let's do the exact same problem. But instead of asking for this ridiculously large number, let's find the sum of the first 5 terms. Or even 10 terms is fine. So now this is S10. A1 is 2. So this is 1 minus, the ratio is still negative 4. Negative 4 to the 10th. And 1 minus 4. So obviously the denominator is still 5. I have 2. Now we can do 4 to the 10th. Right? So I think the TI-84 now is going to handle that. So I'm going to do 1 minus parentheses minus 4 close raised to the 10th. I think this calculator can handle this now. Perfect. It gave you this answer, and all I have to do now is divide by 5. So I'm going to write this thing here. So this is the 1 minus, so this is minus 1, 10, 48, 575. 48, 575. And the calculator can do this no problem because, we don't get into the issue of, I'm going to multiply by 2 and I'm going to divide by 5. We don't get the issue of getting into exponential forms, a scientific notation form, which is a problem. So 41, 94, 30. There you go. Okay, so either a whole number or a fraction, never a decimal or never a scientific notation format number. Now, another way that you may be presented a question is using the summation notation. Now, and notice, so this is a much more important question than the previous, which was just an application of the summation formula. This is, they are telling you, just find the sum. So the very first thing that we need to do is we have to figure out that this is a geometric sequence or a arithmetic sequence. Now, it maybe should be obvious to some that this is geometric, but let's find out. Well, how do we find out? Well, let's find the first three terms. Okay, so the summation says we're going to start with I1 and we're going to end at 10. But let's find the first three because that's all we needed. So 6 times 2 to the 1, comma, 6 times 2 square, 6 times 2 cube, and so on and so forth until the 10th. So let's find out what this is. So this is obviously 12. This is 24. And this is 2 to the 8. I'm sorry, 2 to the 3rd, which is 8 times 6, 48. So I can see from here, this is geometric, right? The ratio is 2. So this is all I need to know. I needed to know the ratio. I know that this is geometric now, and I know the first term. So once I know that, I can go back to the formula. Let's see if I can scroll up a little bit so you can see the formula. So here is the formula. Now notice what I'm gonna put here is I need to find the summation up to the 10th. So the first 10th, so this is S10. A1, which is 6. Is it 6? No, it's not 6. This is the first term right here. Right? 6 times 2 to the 1, 12. 12, 1 minus the ratio, which is 2 to the power of n, divided by 1 minus the ratio, which is positive 2. Okay, so obviously this is -1, so I'm going to get -12, 1 minus 2 to the 10th. Now, I'm pretty sure the calculator can handle this, the TI-84, so we don't have an issue needing to use the scientific, but I can do that. We could do that. So let's do, okay. So let's do this. So let's do the inside first. So 1 minus 2 to the power of 10. And all I have to do now is multiply by -12. I'm just going to multiply by 12, and then I'll flip the sign. So this is going to be 122.76 positive, right? Because I needed to multiply by a -12. So 122.76. So this is 122.76. So it's not a big deal, right? So the question may be given to you in this summation notation. in that case, you are going to first determine the first, maybe first, second, and third, and confirm what the ratio is to determine that this is really geometric. Okay? And then you just apply the formula as we did. Be very careful, right? Because it's these questions, depending on how big n is, it may be better to use a scientific calculator instead of the graphing TI-84. Now, what if we don't want to stop at a particular point, right? So for example, in the previous case, we stop at n10. Now, if we do not want to stop at a particular point and we want to find the sum of the infinite series when n goes to infinity, then we need a different formula. Okay, I'm not going to derive the formula for you. So here is the expansion, and the ellipses here indicate that this goes on forever. It never stops. Now, there is a formula for that, but there are conditions that need to be verified first. This is only the formula if and only if this is the case. You have to check. So the ratio has to be less than 1 and greater than -1. So for example, if I have a ratio of 2, like in the previous case, the previous two cases, this is a ratio of 2, and this one had a ratio of -4, that doesn't apply, because then the sum would go toward either positive infinity or negative infinity. So this is what we call, this scenario here is what we call that the sequence is converging, and the sum of the sequence is going to be a finite number. So this is only for finite numbers in the case that the ratio is less than 1 or greater than -1. So you have to verify that before you proceed with the formula. So don't go blindly, okay? You have to check it first. All right, so let's take a look at the example that we have here. These are very, very easy examples. Again, here's an example, and I don't have to tell you that this is either infinite or geometric. So this is not going to be provided for you on the exam. So find the sum of this series. Now, so number one, how do I know this is infinite? Because it doesn't stop. So this is infinite. Or how do I know this is geometric? I can confirm by finding the ratio. Okay, so we can check two ratios. I'm going to find this one and I'm going to find that one. And if those two are the same, I am going to say that this is a geometric series. Okay, so 316 divided by, actually minus 316 divided by 3/8. So minus 316, flip, right? So this is -8/16, which is -1/2. All right. Now I can check these two to confirm that the ratio between them is also the same and fixed. 332 and -316. So 332 -16/3. The 3's again cancel. -1632 is -1/2. So they're both the same, which means that this is a geometric series according to the problem, but this is how you would verify it on the exam, where this is not going to be provided for you. Okay, so now the question is, I already know this is an infinite geometric series. I found out the ratio. So the next question is, before applying this formula, is this a series that has a finite sum? Meaning, does the sum converge? And the answer is yes, it converges because the ratio is less than 1 and greater than -1. It's -1/2. So it's less than 1 and greater than -1. So we're good. So we can apply this formula here. Okay, so let's do that. I'm going to do this down here. Actually, I'm going to erase all of this stuff. I don't need it anymore. And we can do the work here on the corner. So sum, and notice there is no n here. Don't put an n here because this is not a finite. This is not a finite series. It's an infinite series. So just S. A1, 1 minus the ratio, which was -1/2. Now, you cannot give us a decimal, right? The answer has to be given as a fraction. Even though in this case the question doesn't say it, you cannot give a decimal. So 3/8. This is 1 plus 1/2. Obviously, you can find a common denominator if you remember. Right? So this is 3/2. Okay? So 3/8 divided by 3/2. Now, again, if you don't remember how to do this, so, review this, how to add or subtract fractions with different denominators. Just watch a YouTube video for 5 minutes and you'll remember how to do it in case you don't. Okay, so now division of fractions, flip the denominator fraction, and we have 2/8, which is 1/4. So this is equal to 1/4. This is the answer that we want. Okay. Well, Professor, but we could have written, yes, I know, in this case you could, but there's going to be situations where this is not going to be a finite decimal expansion. You may have something like this. Now, in that case, you have 3, 3, 3, 3, and you cannot chop it off or truncate after 4 decimal, for examples, because this is not the sum. This is the sum. So we need to see the final answer in fraction format, okay? All right, very good. Now, so this is very, very basic, just an application of the summation formula. And the only application that we're going to see in this section is one that is very, very practical. I think it's very important for you to consider that. And it may be on your first exam, and it definitely may be on your final exam, which is this one right here, these two. So I have example 9, and I gave you an additional example, which is example 10, or at least I call it example 10. So express 0.7 as a fraction in lowest terms. Now, notice that the 0.7 has a bar on top. So that bar indicates that the digit 7 is repeated forever. Okay? It doesn't stop. Now, so the first question is, how do I proceed? Now, we have to notice that this is a geometric sequence, and if we add the terms, it becomes a geometric series. So this is the expansion. This is in your book. So this is going to be 7/10, right? The first 0.7 plus the next digit right here would be, and I'm going to write it here, 0.07 over 100, right? 1 and 2 zeros. And what I actually meant to say was this digit is 7 over 100 because it is 0.07, right? So ignore this digit, 0.07. I already have the first one here, 0.7. And now I'm going to add the next. And then the next digit is going to be 0.07, 0.0, another 0 here, 0.007, and this is 7 over 1,000. All right, so 7 over 100, 7 over 1,000, and so on and so forth. Okay, so you can see, I'm going to erase all of this. You can see right here that this is a geometric sequence, right? Well, how do we know that? Let's find the ratio between these two and confirm the ratio between these two. So 7 over 100 divided by 7 over 10. 7 100 times 10 over 7, and this is obviously 1/10. Let's confirm this ratio. 7 over 1,000. 7 over 100. 7 over 1,000 times 100 over 7. 100, 1,000, and again 1/10. So they match. This is a geometric series where the ratio is 1/10. All right. Now, once you figure that out, and it's, by the way, it's always going to work out the same way. This is a geometric sequence where the ratio is 1/10. The first term is this, 7/10. Now, this is the ratio and it's less than 1, so this is going to converge. I can use this formula here. So once I know that, I just can easily apply the formula and get my solution. The sum is A1 over 1 minus the ratio. 7/10. This is obviously 10 over 10. So 9 over 10 multiplied by the reciprocal. And we have 7 over 9. So this 0.77777 forever is exactly equal to 7 over 9. And this is the value that we want. Now, you cannot write this as a decimal, right? Because the calculator is going to stop after a while. Right? So 7 divided by 9, right? Now, it gives you 0.777 and 8, but you know that it doesn't stop at 8. It goes on forever. So we cannot represent this as a decimal. It has to be a fraction. Now let's take a look at the second example, which is identical, but now it has 2 decimals instead of 1. It's kind of very similar, but now I have 0.83 bar. Now, so the repeating is 83. And it goes on forever. So it's 83, 83, 83, 83, 83. So I'm going to write this again as in fractional form. So this is going to be 83 over 100 plus now 0.0083, which is 83 times over this. And same thing as before, now 0.000083. Now 1, 2, 3, 4, 5, 6, and so on and so forth. This looks like a geometric sequence, and we can check the ratio here. I'm only going to do 1 because this is going to be the same. So the ratio is going to be 83 over 1 with 4 zeros, and 83, 1 and 2 zeros. So 83 here times multiplied by the reciprocal. The 83's cancel. I have 100 over this, and the ratio is 1 over 100. So this is certainly a ratio that is less than 1. I can use the formula. I know the first term. I can apply the summation formula. So A1, 1 minus 1 over 100, and do the same thing again, right? 83, 100. This is going to be 100 over 100. So this is 99 over 100. And 83, 100 times 199. This is 8399. Now, um, do not always think that the answer here is 99, okay? It's not going to be. If I have a different ratio, for example, if the ratio is 4/7, so we have 1 minus 4/7. It has nothing to do with the number 99. So don't think it's always the same. Now, on the exam, you may get a question like this, and you must do it this way, all right? So sometimes the students may use some kind of a shortcut they looked on the internet, but this is the only way to do it, proving that the sum is convergent or finite. So don't do it any other way, doing some crazy multiplication stuff, because it's not going to be a lot. So you have to first identify this as a geometric sequence whose ratio is less than 1, and only then you can apply this formula here. Okay, so this is all that we have to cover for the second part of section 10.3, geometric sequences in series. And in this case, we're analyzing either the sum of the first n terms or the sum of the infinite series.